You are not an expert just because you can query a chatbot, presents Staying SOTA, honest and super recent AI news. Today's news from the AI ecosystem. Is AI reading your soul or does it rewire your brain? How fast is the new Google Gemini? Is your boss spying on you with AI? And what is the buzz about self-teaching AI? First up, Neurology Say just unveiled Kopernica, and this is the real deal for emotional AI. The US European company Neurologica has introduced Kopernica as the first AI platform that can capture, interpret, and adaptively respond to human emotions through the combination of multimodal inputs such as facial recognition, voice analysis, and behavioral monitoring. Here's what makes this actually interesting. The 3D pattern recognition system monitors 790 reference points on the human body. That's 7 times more than comparable developments. We're talking about a system that combines visual, auditory, and psychological signals to detect complex states like cognitive load, attention, and stress. But the real technical breakthrough, edge computing architecture, local data processing on the end device ensures privacy and real-time capability, which is essential for industrial use. So they're processing emotional data locally, not sending it to the cloud. As Juan Grania, their CEO, puts it, this technology overcomes a critical limitation of today's AI systems, which understand what we say, but not how we feel. The Kopernica platform will be widely available from the second half of 2025. The company is partnering with over 50 international research institutions and opening a US office in San Francisco. This isn't just another emotion detection demo, it's the first platform that can actually adapt its responses based on your emotional state in real time. This one's wild because it's the first study to actually measure brain activity while people use AI tools. MIT researchers split participants into 3 groups: LLM users, search engine users, and brain-only, no tools. They tracked cognitive load with EEG while people wrote essays. The results? EEG revealed significant differences in brain connectivity. Brain-only participants exhibited the strongest, most distributed networks. Search engine users showed moderate engagement, and LLM users displayed the weakest connectivity. Cognitive activity scaled down in relation to external tool use. Basically, using LLMs to write makes your brain lazy. The study also notes that LLM users struggle to accurately quote their own work, which makes sense given that it was more the LLM's work. But this isn't the first study showing this pattern. A January 2025 study titled AI Tools in Society, Impacts on Cognitive Offloading and the Future of Critical Thinking found that younger participants exhibited higher dependence on AI tools and lower critical thinking scores compared to older participants. And here's the kicker. A Microsoft and Carnegie Mellon study of 319 knowledge workers found that participants with higher confidence in AI tools held lower confidence in their own critical thinking skills. It's like the gym analogy teachers have been using. You go to the gym to make your muscles bigger, not to lift weights really fast. Using AI to think for you doesn't make you smarter, it makes your cognitive muscles atrophy. Google just made Gemini 2.5 Flash and Pro generally available and introduced Flashlight in preview. We designed Gemini 2.5 to be a family of hybrid reasoning models that provide amazing performance while also being at the Pareto frontier of cost and speed. Flashlight is the interesting one here. It's their most cost-efficient and fastest 2.5 model yet. 2.5 Flashlight has all-around higher quality than 2.0 Flashlight on coding, math, science, reasoning, and multimodal benchmarks. It excels at high-volume, latency-sensitive tasks like translation and classification, with lower latency than 2.0 Flashlight and 2.0 Flash on a broad sample of prompts. The smart move? It comes with the same capabilities that make Gemini 2.5 helpful, including the ability to turn thinking on at different budgets, connecting to tools like Google Search and code execution, multimodal input, and a 1 million token context length. So Google is basically giving you a model hierarchy. Flashlight for fast, cheap tasks, Flash for balanced workloads, and Pro for heavy reasoning. They're targeting different use cases instead of trying to build one model that does everything. Companies like Spline, Rooms, Snap, and SmartBear have already been using the latest versions in production. This isn't beta software anymore, it's production-ready infrastructure. The Plaud AI situation is getting real. I covered this before, but the scale is accelerating. Plaud now has 1 million users, mainly in the US, followed by Japan and France. The devices, Note and NotePin, are coming to Best Buy this August. Here's what's actually happening. Tiny microphones on the device record the wearer's conversations, with up to 30 hours of recording time per charge on the Plaud Note and 20 hours on the NotePin. The Note slips into a pocket on the back of a phone or a button-down shirt. Most of its customers are corporate executives. The AI processing uses Google's Gemini 2.5 Pro, OpenAI's GPT 4.1, and Claude 4 to transcribe and summarize conversations. Around 20% of Plaud users are doctors, and the system is now HIPAA compliant. But here's the concerning part. The company's CTO openly says, will people report problematic coworkers to HR by sharing a conversation Plaud recorded? I think that will happen. And get this, we debate internally if the device should always be on, but for now it's not. The appropriate etiquette is probably to tell others when they are being recorded, but if the devices become common among employees at a certain company, everyone may assume they are being recorded all the time. We're sleepwalking into a workplace surveillance state, one tiny recording device at a time. The final story is about MIT's breakthrough called SEAL, Self-Adapting Language Models. And this is genuinely wild because they figured out how to make LLMs update their own parameters in real time based on new information. Here's the concept. The initial idea was to explore if tokens could cause a powerful update to a model, says Jyotish Pari, a PhD student at MIT. The system generates its own synthetic training data and update procedure based on the input it receives. So instead of retraining the whole model, SEAL generates new insights and then folds it into its own weights or parameters. Given a statement about the Apollo space program challenges, for instance, the model generated new passages describing the implications. The researchers compared this to how human students write and review notes to aid their learning. The process is clever. The system updates the model using this self-generated data, tests how well the new model answers questions, and uses that as a reinforcement learning signal to guide future updates. They tested it on Meta's Llama and Alibaba's Qwen models. As Professor Pulkit Agrawal, who oversaw the work, puts it, LLMs are powerful, but we don't want their knowledge to stop. The approach could make AI models way more personalized, but there are limitations. The models still suffer from catastrophic forgetting where new information causes older knowledge to disappear. Plus, it's computationally intensive. One fun idea the researchers mention, maybe LLMs need sleep periods like humans to consolidate new information. So here's what's actually happening. Emotional AI is moving from research to production with real hardware. Studies are proving that AI assistance makes us cognitively lazier. Google is building model hierarchies optimized for different use cases. Workplace surveillance is normalizing through consumer AI gadgets, and MIT just figured out how to make AI models teach themselves through synthetic data generation. The pattern I'm seeing is we're moving from AI as a tool to AI as an environmental factor that's reshaping how we think, work, and interact. The companies building ethical frameworks around these capabilities now will have massive advantages later. But honestly, the MIT SEAL approach is the one that excites me most technically. The idea that a model can generate its own training data and update its own parameters, that's getting close to genuine machine learning rather than just pattern matching. Even with the computational overhead and forgetting issues, this feels like a real step toward AI that can actually learn and grow. That's my take on the current developments. The technology is advancing faster than our frameworks for handling it responsibly, and that gap is only getting wider.